Hey everyone, and welcome back for another deep dive. Today we're going way beyond the usual light and sound stuff to explore something totally new and different.
Yeah.
Gravitational waves.
A mind-blowing realm, to be sure.
It really is. And to guide us through this crazy cosmic journey, we have insights from
Oh, yeah.
none other than Kip Thorne,
The one and only.
Nobel Prize winner.
You got it.
This guy practically wrote the book on black holes.
He did.
And even lent his expertise to the movie Interstellar.
I mean, if you want to talk about a fascinating topic,
Right.
this is it. What makes this duck dive so exciting is that we're not just going to talk about what gravitational waves are,
Right.
but what they tell us about the universe that we could never see before.
Yeah.
Like, we suddenly got a whole new sense for understanding the cosmos.
It really is. It's like we're so used to exploring the universe with light, you know?
Yeah.
Everything from the stars we see at night
Right.
to the images from like powerful telescopes. But Kip Thorne is like introducing us to
Yes.
a whole other type of wave.
Mm-hmm.
A wave that doesn't travel through space like light does,
Right.
but rather through the fabric of space-time itself.
It's wild.
Space-time.
Exactly. So imagine space-time as like this giant sheet,
Okay.
and massive objects like stars and black holes create like dips in that sheet.
Yeah.
That's gravity.
Okay.
Now picture those massive objects like moving around, colliding, spinning.
Right. Okay.
Those actions, they create ripples in that sheet.
Right.
And those ripples are what we call
Gravitational waves.
gravitational waves.
Okay.
Well,
Okay. I'm starting to get it. So instead of like looking at the light from distant objects,
Yeah.
we're essentially listening to the vibrations of space-time caused by these incredibly powerful events.
That's a great way to put it.
Okay.
And what's so fascinating is that these gravitational waves carry information that light just can't.
Oh, really?
Like, think about the Big Bang.
The Big Bang.
The very birth of our universe. Light from that event has been like scattered and absorbed over billions of years.
Wow. Yeah, of course.
But gravitational waves,
Yeah.
they would have traveled undisturbed,
Wow.
carrying like a pristine record of those earliest moments.
But you were talking about like potentially hearing the echoes of the universe's creation.
Exactly.
That's incredible.
Thorne even suggests that this would give us a glimpse of the universe's blueprint,
Right.
information that light could never carry through all those billions of years.
It's like a time capsule.
Exactly.
Wow. So it's not just the Big Bang?
Nope.
Think about like the most extreme events imaginable.
Blue
Like
are.
two black holes colliding.
Oh, yeah.
These collisions are so powerful
They are.
that they warp space-time.
They do?
They send out these massive ripples,
Uh-huh.
but they don't emit any light that we can actually see.
Got it.
So if we want to study these invisible events, these cataclysmic collisions of black holes,
Yeah.
gravitational waves are our only window.
Exactly. Telescopes, no matter how powerful, are useless. For observing those collisions directly,
Right.
but through gravitational waves, we can actually hear those events happening,
Really?
even billions of light years away.
That is mind-boggling.
It is.
It seems like Thorne was way ahead of the curve with all of this.
He was a visionary.
I mean, didn't he predict, like back in the 1980s, that the first thing we detect with gravitational wave observatories would be colliding black holes?
He did.
And he was right.
He was spot on.
LIGO, the Laser Interferometer Gravitational Wave Observatory,
Yeah.
is now detecting these cosmic collisions practically every other day.
It's remarkable, isn't it?
That's remarkable. So what does all this mean for us? For those of us who aren't like physicists,
Right.
but are still fascinated by these discoveries.
Well, it means that we're on the verge of like a whole new era of astronomical discovery.
Wow.
Where we can literally listen to the universe
Wow.
in a way we never even thought possible before.
Yeah.
Think of it as a brand new sense. That's letting us perceive events and objects that were previously hidden from us.
It's like we've been given this incredible gift,
It is a gift.
this new way of perceiving the universe.
Yeah.
That opens up a whole new realm of possibilities.
A whole new world.
And the implications
Huge.
are huge.
They are. We're not just talking about witnessing these dramatic events like black hole collisions.
Right.
Gravitational waves can also tell us about the more subtle movements and interactions
Okay.
of objects throughout the cosmos.
You mean like the way galaxies evolve?
Exactly.
The dance of stars within those
Yeah,
galaxies?
you got it.
Maybe even the behavior of matter under extreme conditions that we could never replicate here on Earth.
Precisely. It's like having a cosmic microscope
Wow.
that lets us zoom in on the intricate details of the universe's workings.
This is where I find it so exciting.
Me too.
Thorne isn't just telling us about, like, a new discovery.
Nope.
He's painting a picture of a future where gravitational wave astronomy completely reshapes our understanding of the universe.
It does.
From the smallest particles to the largest structures.
Absolutely. And what's so exciting is that we're just at the beginning of this journey.
We are.
We've only just begun to listen to the universe.
Wow.
In this new way.
So where do we go from here?
That's the big question.
If we've gone from seeing the universe with light to hearing it with gravitational waves,
right.
What other senses might we develop in the future?
That is a great question, and who knows?
Yeah.
We've only scratched the surface of what gravitational waves can reveal to us.
Right.
Who knows what other mysteries and wonders are out there waiting as we delve deeper into this new realm of cosmic exploration.
All right, I'm hooked. Let's continue our deep dive and explore some of those mysteries.
Let's do it.
So we've talked about how gravitational waves can, like, reveal the universe's birth.
Yeah.
And its most dramatic events like black hole collisions.
Right.
But what about, like, those whispers you mentioned earlier?
Oh, yeah.
Those subtle movements and interactions happening all throughout the cosmos?
Mm-hmm.
What can those tell us?
Well, one area where gravitational waves could totally revolutionize our understanding is in the study of neutron stars.
Neutron stars.
Yeah.
Okay.
These are like incredibly dense remnants of collapsed stars.
Yeah, okay.
Packed with matter so tightly that like a teaspoonful would weigh billions of tons.
Wow, billions of tons in a teaspoon. Okay, you've definitely got my attention.
Wild!
What makes neutron stars so interesting from a gravitational wave perspective?
Their immense density means they have like incredibly strong gravitational fields.
Okay.
And when two neutron stars orbit each other, they emit gravitational waves that carry unique information about their structure and composition.
So by listening to these gravitational waves, we could learn about what's happening inside these extreme objects.
Exactly.
Something that's impossible to do with, like, traditional telescopes.
It's like having a stethoscope pressed against the surface of a neutron star.
Okay.
Allowing us to hear its heartbeat.
Right.
And decipher the secrets of matter under such extreme conditions.
That's amazing. It seems like every time we talk about gravitational waves, the possibilities just keep expanding.
They do.
And speaking of expanding possibilities, we can't ignore the elephant in the room, or should I say the wormhole in the universe. The tantalizing possibility of time travel.
Time travel.
I have to admit, every time I hear those two words together, my imagination goes into overdrive.
Of course.
And Kip Thorne has some intriguing ideas about how wormholes,
He does.
these theoretical tunnels through space-time, could potentially be used for time travel.
It's important to remember, though, that this is all highly theoretical.
Right.
Thorne himself even acknowledges that current evidence suggests that, like, backward time travel on a human scale is unlikely, although it might be possible on a subatomic level.
Okay, so maybe we're not hopping into time machines just yet.
Not quite yet.
But the fact that we're even having this conversation is a testament to how much our understanding of the universe has expanded.
It really is.
Thanks to gravitational waves.
It's incredible.
Thorne's work with wormholes highlights how gravitational waves can push the boundaries
They do.
of what we thought was possible.
It's mind-blowing.
His theories, even if speculative,
Right.
encourage us to question our assumptions about the nature of time and space.
To think outside the box?
I remember reading somewhere that Thorne even proposed, like, a specific scenario
He did?
involving a wormhole with two mouths.
Yes.
Can you remind me how that works?
Sure. Picture a wormhole with one mouth here on Earth
Okay.
and the other attached to like a spacecraft, capable of traveling at near light speed.
Okay.
The spacecraft journeys out into space for a year, then returns to Earth.
Okay.
Now, because of the effects of special relativity,
Right.
time would pass differently for the traveler and those on Earth.
Okay, I'm following you so far. So we've got one mouth staying put on Earth and the other blasting off into space at nearly the speed of light.
You got it.
How does that create a time difference?
Well, it all comes down to this fascinating concept
Really?
called time dilation.
Time dilation.
Yeah, a consequence of Einstein's theory of special relativity.
Okay.
It essentially means that time passes slower
Okay.
for objects moving at high speeds relative to, like, a stationary observer.
So the mouth on the spacecraft would experience time more slowly than the mouth that stayed on Earth.
Precisely.
Okay.
Let's say hypothetically 50 years pass on Earth. while the spacecraft is traveling,
Uh-huh.
due to time dilation,
Right.
only 2 years would have passed for the traveler on the spacecraft.
Wait, so the wormhole mouth on Earth would age 50 years?
Uh-huh.
While the one on the spaceship only aged 2 years?
Yeah.
That's wild.
It is, and it gets even weirder,
Oh, no.
according to Thorne's theory. If you were to pass through the wormhole from Earth to the spaceship,
Yeah.
you would essentially jump back 48 years into the past.
Okay, my brain is definitely doing some time-bending gymnastics right now.
I know, it's a lot to wrap your head around.
But if I understand correctly,
Yeah,
this whole scenario relies on wormholes actually existing,
it does.
which is still very much in the realm of theoretical physics.
Absolutely.
And even if wormholes do exist,
Right.
creating one large enough and stable enough for a human to pass through
Yeah,
presents a whole other set of challenges that we may never overcome.
it's a big if.
So while a wormhole time machine might be a long shot,
Yeah.
Thorne's work highlights how the study of gravitational waves can lead to these mind-bending possibilities
It does.
and challenge our understanding of the universe.
It pushes us to think beyond what we thought we knew.
And Thorne's passion for, blending science and imagination
Oh, yeah.
definitely shines through in his work.
He's a true visionary.
I'm curious, you mentioned earlier that he's written a book about all of this.
I did.
What was it called again?
It's called The Warp Side of the Universe.
Okay.
And it's a fascinating read.
Yeah.
He does a fantastic job of explaining complex scientific concepts in a very accessible way,
Right.
while weaving in artistic interpretations of
Got
these
it.
mind-bending ideas.
I'll definitely have to check it out.
You should.
But shifting gears a bit,
Okay.
let's bring this back to the present
Right.
and the incredible discoveries already being made
Yeah.
with gravitational waves. We
Right.
talked about black holes,
Mm-hmm.
neutron stars,
Yep.
and even the echoes of the Big Bang.
It's a lot to take in.
What's next for this field? What other secrets is the cosmos whispering to us? It feels like we've only just dipped our toes into the ocean of possibility
We have.
with gravitational waves.
It's a vast ocean.
What's really exciting to me is the idea that this is just the beginning
It is.
of a whole new era of astronomical discovery.
Absolutely. We're essentially witnessing the birth of a new field,
Wow.
gravitational wave astronomy.
Okay.
And it has the potential to revolutionize our understanding of the universe
Yeah.
for centuries to come.
Think about it. 400 years ago, Galileo pointed his telescope at the sky
Mm-hmm.
and changed our view of the cosmos forever.
He did. He did.
We went from a geocentric universe to a heliocentric one.
A big shift.
Now with gravitational waves, we have another tool,
Yeah.
another sense
Right.
that's allowing us to perceive the universe in a completely different way.
It's like we've gone from watching a silent movie
Okay.
to suddenly having a full symphony orchestra playing along with the visuals.
Wow.
We're no longer just seeing the universe. We're
Right.
hearing it,
Yeah.
feeling its vibrations.
Thorne refers to this as
He does.
multi-messenger astronomy,
Mm-hmm.
combining traditional electromagnetic observations
Mm.
with this new ability to detect gravitational waves.
Exactly. It's a powerful combination.
It is incredibly powerful by combining these different messengers.
Yeah.
We can get a much richer
Yes.
and more complete picture
Uh-huh.
of the universe.
So we can compare and contrast what we see with light
Okay.
and what we hear with gravitational waves,
Right.
filling in gaps in our knowledge
Yeah.
and uncovering new insights that were previously hidden.
You mentioned earlier that we could potentially study the evolution of galaxies
We can.
using gravitational waves.
Yes.
Can you expand on that a bit?
Sure.
What kind of information could we glean from these cosmic mergers and interactions?
Well, imagine two galaxies colliding.
Okay.
A truly epic cosmic event.
Wow.
These collisions involve the movement of billions of stars,
Yeah.
vast clouds of gas and dust,
Uh-huh.
and supermassive black holes at their cores.
Got
And
it.
all of these movements generate powerful gravitational waves
Right.
that carry a wealth of information
Okay.
about the dynamics of the collision.
So we could actually track the movements of those galaxies,
Yeah.
see how their structures change, how their stars interact, all through the lens of gravitational waves.
Exactly. We could study how these collisions trigger bursts of star formation,
Wow.
how the central black holes grow and influence their surroundings,
Okay.
and even how dark matter,
Dark matter.
that mysterious substance that makes up a significant portion of the universe,
Right.
behaves during these events.
That's incredible. It feels like we're on the verge of unlocking
We are.
so many secrets about the universe.
There's so much more to learn.
Things we'd never even dreamed of studying just a few decades ago.
It's an exciting time.
So for our listeners who are now just as captivated by gravitational waves as we are,
Yeah,
where can they go to learn more?
that's a great question.
What resources would you recommend?
Well, the LIGO website is a great place to start.
Okay.
They have tons of information about how gravitational waves are detected, the latest discoveries, and the future of the field. NASA also has some excellent resources on gravitational wave astronomy, including articles, videos, and even interactive simulations.
Cool.
And of course, we can't forget Kip Thorne's book,
Oh, yeah.
The Warp Side of the Universe.
I'm already adding it to my reading list.
It's a must-read.
Well, this has been an incredible deep dive, to say the least.
It has been.
From the echoes of the Big Bang to the collisions of black holes,
Yeah.
from the dance of neutron stars to the mind-boggling possibilities of time travel.
It's a lot.
Gravitational waves have truly opened up a new window to the universe.
They've given us a whole new way of seeing and hearing the cosmos.
And it's been a pleasure exploring these concepts with you.
Likewise, the pleasure was all mine.
And I hope our listeners are leaving with a renewed sense of wonder and curiosity
I hope so too.
about the vast and mysterious universe we inhabit.
It's a beautiful and awe-inspiring place.
It really is. It's a reminder that there's always more to learn,
Always.
more to discover,
Yeah.
and that the pursuit of knowledge is a journey without end.
A never-ending adventure.
So keep looking up, keep asking questions, and keep exploring the depths of knowledge.
That's the key.
You never know what mind-glowing revelations await.
You never know what you might find.
Until next time, keep diving deep.
And never stop exploring. The